Could I have your attention, please? We have been passing the board around and for program suggestions, and it looks light.
Is that, your mic is not, I don't think. Can't hear you. Get up close to it.
Can you hear me now?
Yep. There you go.
Can you hear me now?
Yep. Yeah.
Sort of vaguely, but not as well as we should be able to hear you.
Well, do you want me to get in my preaching voice?
That's good.
You turn the volume.
What do you want? Pen. Is that your pen? No.
I want a show of hands of who's going to help us next week to plan out next fall's. I don't see enough hands up. Come on, everybody's got to help here. Austin, are you going to help?
I'm sure he'll be.
Huh?
He'll be here.
Perhaps.
Perhaps. A definite perhaps. Let me count again. 3, 4, 5, 6, 7, 8, 9. That's barely enough to get the job done. But we've got some great ideas
You do?
to work through. I mean, I went to bat and Dennis went to bat, but we need your input too.
Okay.
We need good, solid ideas by real people who know how to put together a real program. Now I have good news today.
Yes?
Lauren Henderson has reported to the board of this institution
Yeah.
that they have recovered their charitable status.
Oh, good.
So the thousands of dollars you were planning to give this year, even 100 will be acceptable, but 1,000 would be better. You can be assured that you'll get a tax write-off.
Super.
You think I'm kidding? We need big bucks, and we'll be on a roll if we can get more support. So
How
let's,
about flattening out the parking lot?
well, there's some preliminaries that have to happen before that happens. And it's all determining, it's all about money, as it is in every institution that I've ever been
It's
associated
always
with.
about money.
Everybody wants more.
Yeah.
Well, we have I'm not sure if this is the title of the program today, but we're going to learn about it anyway because Earl's here and he wants me to brag on him for all the things he's done in his life. My God, it wears me out just trying to read it. Go back clear to 1945.
44.
You're younger than I am, if that's your birthday.
Give us the
Oh,
short
it isn't your
version.
birthday.
Give us the short version.
Well, I'm
He's got the United States Navy is in the future there, and then a V5, whatever that stands for, and then something about UMSU and Brown University. And then in 1948 to 1944 to 48, he was a BS graduate from, or in school at mathematics at Missouri Valley College. And from 1950 to 55, he had an MS and PhD, EJS Mathematics, University of Illinois. And from 55 to 57, he was an instructor in mathematics at the University of Nebraska. And from 1957 to 61, assistant professor of mathematics at Iowa State University. And then from 1969 to 59, you got 69, but
Okay, that's
1959 to 61, he was in charge of operations and programming, I guess, at ISU. And then from 61 to 63, he was with the National Security Agency. In 63 to 68, he was associate professor of computer science at the University of Maryland. And 1950 to 1968, he was in the U.S. Navy Reserve, weekly duty in a security group. And from 1968 to the year 2000, he was professor of computer science, EEES the University of Kansas. And I guess from 2000 till now, you've been loafing. Pretty well retired, almost,
Completely retired.
but good enough to give us a good program today. We welcome you, Earl. I'll leave that with you.
Well, first of all, no matter how hard I tried to get technology to work, it never does. Okay? You wouldn't believe how much effort I tried to get us for a mic that you don't have to keep your face in front of this darn thing. Okay. Part of the problem is that this projector down here, which I had a minor role in our getting more than 10 years ago, is totally out of date. We're going to have to do something about that. Because every current computer, this one I bought last summer, has Windows 10 on it, which I never opened up until yesterday. And I barely learned enough to, I thought, coordinate this with that. But unfortunately, he can't deal with the output of a current Windows machine. But that proves over and over again what I've been telling people for 60 years. Computers are no damn good. I have more evidence than almost anyone else in town to prove that. Okay. This talk is stimulated by this book by Stephen Hawking. The title is on the screen.
Use the mic, we can't hear you.
Yeah, you need to talk
Okay.
louder into the mic.
Okay. So, the book contains information about 17 mathematicians who Hawking considers are the most important to him. I will introduce you to a few more. The term, God created the integers, dates back to that gentleman by the name of Leopold
Earl, I'm
Kronecker.
still having
We can't
trouble
hear you
hearing.
very well. You need to go back
Okay,
from the
that better?
microphone.
He'll up the
You need to
volume.
pull it up near your mouth,
Okay.
up
Take it
near,
off and hold it up to
near
your
to
mouth.
your mouth, and then talk louder.
Okay.
Yay!
Okay. Kronecker is credited with this term that God made the integers, all else is the work of man. Of course, God made men, so anything men do is also ultimately God's work. Now, I have a problem that I have to move both of these things at the same time. Since we're talking about the integers, some of you don't know what the integers are. And I do not know anyone who knows that God created them, but I'm not going to argue that point if he created everything else. Unfortunately, God never revealed to human beings, as far as I know, that he had created the integers, because we went for centuries before we finally understood the integers. In early languages, there were only 3 words for numbers: 1, 2, and many. Now, so we need to go through this, and this is based on Wolfram's mathematical math world, which is a huge online compendium of information about mathematics. Counting numbers are the basic numbers, classically starting at 1, 2, 3, 4, and so on. And that has been around for a long time. The problem is not with the numbers, which are abstract things. You can't buy one, you can't sell one, you can't even see one. such numbers are used in two sentences. One sense, one is to count, and one is to quantify an amount. Okay? You have first, second, third are the ordinal numbers, in order. 1, 2, 3 are the cardinals. Okay. So, the natural numbers are the counting numbers. 0 originally was not involved in that set. It was not an accepted number as late as 1202, as I'll show you later. So today, some people, including Wolfram, advocate that we refer to the integers from the Zahlen Z, which is the set of positive numbers and numbers 0 and the negatives of the positive number. So you have the integers, the positive integers, the non-negative integers, which includes 0, the non-positive integers, which is just the negatives, and the non-positives, which include 0, and the negative integers, which doesn't include 0. Okay. So, okay. Now, you have to be very careful about two aspects of this. There are the numbers, and there are several different kinds of numbers beyond the integers, which we'll get to. They are abstract things, as I say, they don't exist. And then we have to have verbiage to talk about these things. And that, what happened here? I got ahead of myself. Okay. So numerals versus numbers. Numbers are the actual numbers which are abstract. Numerals of various kinds are things we can write down or say when we talk about numbers. Okay? Now, I used to teach a course 3 or 4 times, maybe 3, in the history of computing, not the history of computers. We started out with things like the Egyptian hieroglyphics. Egyptian hieroglyphics, you can see here, are it's an additive system like the Roman numerals, so that if you want 2, you put up 2 ones. If you want 3, you put up 3 ones. Okay? Or 3 eyes or whatever. The Greeks had 2 forms of numbers. One of them called the Attic system, which was a precursor to Roman numerals. And you can see, put this one down. You can see along the top here are the Greek numbers. At the bottom are the Roman numerals. The Roman numerals were derived from the Greek Attic numbers. The Greeks had a second system which used the first letters of the Greek alphabet for 1, 2, 3, up to 8, up to 9, excuse me. And then for 10 through 90, they used different Greek letters. And for 100 through 900, they used another set. That didn't go very far. The point is that none of those systems would allow us to do the mathematics that we've been doing for the last few hundred years. Okay. This brings us to 0. I have an entire book here on the history of zero. How it took centuries to, despite disputing whether that was a legal thing or not. Okay? It's now well accepted.
Why is a zero so long feared and forbidden?
Well, so some of the arguments were it destroys. No matter what you apply it to in multiplication, it kills it. On the other hand, if you're in addition, you add it to anything and it does nothing to it. There are all sorts of arguments in this book if you want to know. I have a former insurance agent in town who read this whole book when I told him about it and thought it was very interesting. But anyway, zero was a problem. It still is to some extent. Okay. I don't know whether you've heard of the House of Wisdom or not. How many people have heard of the House of Wisdom? Anybody? For 500 years, the center of academic things was in Baghdad. The most prominent institution there was the House of Wisdom. They drew in Christians, Jews, all sorts of people from the East and the West, and preserved and developed all kinds of knowledge. This was during the Dark Ages in Europe, when nothing was happening in this area. Among other things, the slide here. How many of you have heard of Leonardo? Okay. He is the person who brought the decimal numbers from the East, are normally called the Hindu Arabic numbers today, to Europe. And in 1202, he wrote a book on that, and that was when we finally got in Europe the decimal numbers, which make it possible to move on to other things. Now, a little detail here from a different era. You've heard of Tiny Tim, I'm sure. Tiny Tim's father was the accountant for Scrooge, as you know. And what did he do? How did he do his accounting work? He did that on a board with jettons, which were specially coined like money to do the counting. There were several different varieties of these, and they were used to move around on this board to do the mathematics to keep track of Scrooge's money.
What's a jeton?
What?
See the one down the bottom there, J-E-T-O?
Jeton
What's that?
is a little coin-like thing.
A
And
what?
these coins were
A coin?
coin,
Oh, okay.
like a quarter,
Mhm.
okay? Probably about the size of a quarter,
Okay.
which were used on this table to move around to do the calculations.
Okay.
Actually, in Europe, the abacus was apparently heavily used in Europe, and then they stopped using that and did this computation on what were called boards. And some of these, like for stock exchanges or something like that, some of these boards were huge physical things.
Really?
So, now, this is another interesting little aspect here. We're going to get into the rational numbers now. We know what the integers are. The rational numbers are quotients of two integers. the denominator can't be 0. There are multiple meanings for the same number. As you can tell on the screen, if you look at the diagonals this way, you see that 1 over 1 is the same as 2 over 2 is the same as 3 over 3. So you have a long, in fact, infinite number of representations of 1 or a half, or everything. Every rational number has an infinite number of representations. So, and this also proves, if you follow it through the arrows there, proves that there are no more rational numbers than there are not positive integers. Now that's mind-boggling because each rational number has as many representations as the integers. Okay, you all heard of Galileo Galilei? How many people have heard of Galileo Galilei? Okay, he had a little bit of a dispute with the Pope, among other things, because he believed in heliocentricity. The sun is the center of our area, and the Pope still believed that the Earth was the center for some reason, and that was a major debate. But among other things, he did extensive research, which I didn't know until recently, on give me just a minute, on gravity. He slowed down gravity by, instead of dropping an object up high, it moved too fast. So he used a slatted board with a groove in it and put metal balls down it so it would function slowly. And he could count how long it took for the ball to roll because of gravity. And he was counting this off in terms of heartbeats, was the most accurate thing that he had at that time to count that. And he proved essentially some of the mathematical relationships between gravity and the motion of a falling object. That was before Newton, by the way, we'll get to